To the third lesson of Mathematics IGCSE course. This time we are talking about approximations and estimation. We will cover two syllabus objectives, which are E 1.9, make estimates of numbers, quantities and lengths, give approximations, and also a round of the answers to reasonable accuracy, of course. And E 1.10, give appropriate upper and lower bounds for data given to a specified accuracy, obtain appropriate upper and lower bounds to solutions of simple problems given data to a specified accuracy. Okay, let's get going. First of all, approximations. Write the numbers correct to, you see we have a nearest whole number, three significant figures, and two decimal places. Let's start with the first number, which is 8.174. The nearest whole number, of course, if you think about 8.174, the nearest whole numbers are 8. There's 8 on one side, and then there's 9 on the other side, right? If we kind of try to measure it on the ruler, right? So there's 8 and there's 9, and of course it's way closer to 8. So 8 is the nearest whole number. Three significant figures. So significant figures are any figures in a number which are not zeros on the left. So I think when we get to number 4, I will explain more about significant figures. But for now, let's just see. So this is the first significant figure, that's the second one, and that's the last significant figure, the third significant figure. So this is where we make a stop at 7, and we round it after 7. So after 7 we have 4. So we have to, it's not going to go up, it's going to stay like this. It's going to be 8.17. That's the three significant figures. Also sometimes you would see it written like this, 3SF. This is for significant figures, and two decimal places can be written like this, 2DP. I see this in past papers quite often. So instead of decimal places, there will be DP written, so this is abbreviation for decimal places. So two decimal places, that's the first decimal place, number 1, and this is number 2, so 1, 2. So also, if you round it like this, it's going to be 8.17 to two decimal places. Okay, next one. So here we have 19.617. Nearest whole number is going to be 20. All right, 19 is between 19 and 20, 19.6, and it's closer to 20. So you can just look at this number, 6. You can see it's closer to 20. B, two significant figures, so that's this is the first, that's the second, and that's the third significant figure. So this is where we're gonna cut it, and we have to look at digit next to 6. It's 1, so it means we're gonna stay. It doesn't go up, it just stays, so it's 19.6. Finally, two decimal places, so that's the first one, and this is the second one. So then we have 6, 1, and after 1 we have 7, so it means 1 is going to go up because there is 7 after it, so it's going to be 19.62 here. Okay, let's keep going. Then we have 20.041. Nearest whole number is of course 20. 3SF, so that's the first one, 1, 2, 3. This is three significant figures, so we're gonna round this last one is 0. After it's 4, so it's gonna stay 0, so it's basically 20.0, which we can just write as 20. Finally, two decimal places, that's the first one and that's the second one. So we look at 4 and we look at the digit next to it, which is 1. It means it's not going to go up, it's going to stay if there's 1. So it's going to be 20.04. Number 4, we have this big decimal number. the nearest whole number. So this number 0.8, to write it shortly, is between 1 and 0, and it's closer to 1. We can see that. So here the answer is 1. For B, 3SF. So this is where it gets a bit tricky. A significant figure, so 0 on the left. This is not a significant figure. So actually we start from 8. This is the first significant figure. That's the second one, and that's the third significant figure. So we look at 4. Right, let's enlarge it. So 0.81452. So 1 significant figure, 2, 3 significant figures. So we look at 5. It's 5. Remember, if it's 5 or more, it means that this number has to go up. So it's going to be 0.815. And finally, 2 decimal places. I think by now you should be comfortable with this. So 8 is the first one, 1 is the second one. So this is where we stop. We look at the next number, it's 4. It means we are staying, we are not going up. So 0.81 is the answer. Okay, next we have the last one actually, 311.14. The nearest whole number, so 311 is between 312 and 311 on different sides. It's closer to 311. Basically saying rounded to the nearest whole number is like saying rounded to the nearest single digit number. You could say that to the nearest one. So like there's a nearest, this is tens. So for example, this is hundreds, you know, right? This is tens. And this is ones. So basically rounding to the nearest whole number is just like rounding to ones. So here we look at this number and we look at the next number. It's 1, it means we're going to stay, basically. So the answer is 311. In B, 3SF, so we go 1, 2, 3, right? So 311 again, so the answer is the same. And 2 decimal places. So there's only 2 decimal places, so we actually don't have to round anything for this example. 311.14. Okay, that's it for approximations. For rounding actually. So this is rounding, what we call it. Okay, bounds. Okay, this is a very good topic. I will try to dedicate some time to this question. So upper and lower bounds. Let's try to talk about this a bit in detail. So it's quite simple if we have to find the largest possible value of a sum. So let's take a look at these numbers. P is 7 centimeters and Q is 5 centimeters, both to the nearest centimeter. So let's try this. So 7 centimeters. Let me try to make this drawing. So let's say let's try to imagine we have a small ruler. Let's say it looks like this. There's 7 here. Then here we have 8. And on this side we're going to have 6. So 7 to the nearest centimeter. So let's think about this. It means that if we can go half a centimeter in this way, in this direction, and we can go half a centimeter in this direction. So this would give us the nearest 1 centimeter. This gives us nearest centimeter. So we split it. We go halfway to the left, 0.5. We go halfway to the right, 0.5. So it means that P is between 7.5 and 6.5. That's the upper and lower bounds for P. Q, in the same way, we could make a drawing of it. Q. At first you can make these drawings, but when you get used to these kind of questions. You obviously don't need the drawings, you can just write this part, and that's going to be enough. So Q is, of course, we start at 5, and we go, so if it's nearest centimeter again, so we go half centimeter in this direction, and we arrive at 4.5, and we go half a centimeter in another direction, we will arrive at 5.5. So Q is between 5.5 and 4.5, in fact. Okay, so now let's get to the actual questions. We need to find out, first of all, we have to find out the largest possible value of P plus Q. Well, that's quite simple. We just take the upper bound of P and upper bound of Q, right? So it's going to be 7.5 plus 5.5 is going to be 13. That's the answer. The smallest possible value of P plus Q, also quite easy, right? So we just take the smallest value, the lower bound for both of them, lower bound for P and lower bound for Q, and we arrive at 11. That's going to be 11, the smallest possible value. Okay, so this is where the interesting part comes in, starting from C, the largest possible value of P minus Q, right? So you may think that what you have to do is you have to take upper bounds for both of them. So you have to do, we have P minus Q. You would probably want to do this, 7.5 minus 5.5. But actually, that's not how you do it. The largest possible value of P minus Q. So we would get 2. But then, wait a minute. What if we do the upper bound of P and the lower bound of Q, right? We would get actually a bigger answer. So this is the largest value. This is larger than what we get when we just subtract upper bounds. So here actually what we have to do is we have to take upper bound of P and a lower bound of Q, and we have to subtract them to get the answer, which is 3. That's the largest possible value of P minus Q. So generally, when you do multiplication and addition, it's quite easy to find upper and lower bound. But when it comes to stuff like subtraction and division, normally you have to think about it a little bit, because normally it's going to be kind of in reverse. So for example, when you do subtraction, we have to take upper bound of P, and we have to take a lower bound of Q to get the actual answer. And next one, D, is even more tricky. Okay, so if we want to find the largest possible value, so okay, just in shortly, the way you should think about this is if you want to find the largest possible value of division, for example, you want to make sure that top is as large as possible and the bottom is as small as possible, so that the result is going to be a biggest number, the as big number as possible. So this has to be as big as possible. The top has to be as big as you can make it, as large as possible, and the bottom has to be as small as possible. And the same goes basically for a subtraction as well. So subtraction here, this number has to be as large as possible, and this number has to be as small as possible. Okay, so saying that, so what we have to do, so P squared has to be as large as possible. So what we do is we take the upper bound for the value of P and we square it. Q has to be as small as possible. So we take the lower bound. So we're going to get 7.5 squared divided by 4.5. So for this part, I'm going to use a calculator, of course. 7.5 squared over 4.5. 12.5 is the answer here. Okay, and of course, if you want to find the smallest possible value, for example, if you want to find the smallest possible value, let's say this is like a D star. Let's say you want to find the smallest possible value of p squared over q. So in this case, the top part has to be as small as possible, and the bottom part has to be as large as you can make it. So if you want to find the smallest possible value. Okay, that's it for pounds. Let's keep going. Next is the estimation. So estimation is quite useful because a lot of people, they tend to skip it, but I believe it's very, very useful because sometimes you make a typo, for example, or you type something, maybe you write something wrong. Estimation just basically helps you to look at the number and think, aha, so the answer should be somewhere in this area. Right, so for example, so what happens, let's say for example I do this calculation. Let's imagine this scenario that I want to do 7.2 times 9.8, and let's say I forgot to put the point. So let's say I do 7.298, right? So the answer I get is 700, and at this point, if you're good at estimation, you should be like, wait, like this is not what I'm supposed to get, because these numbers, 7.2, it can be rounded to, so let's actually do this. This can be rounded to 7, and 9.8 can be rounded to 10 when you round it to the nearest whole number, and it should be 70, right? So if you get the answer 700, you should be like, wait, this is not even close to what I should be getting. So that's why we use estimation. And here the answer is this 70.56 because we see it's the closest one to our estimation. Okay, let's try next one. So in the number 2, 2.03 times 58.6. We should be trying to round them within the reasonable within the reasonable range. So don't round them too much. So 2, let's round it to 2.03, we can round it to 2. 58.6, we could round it to 59 as like to the nearest whole number, but actually I think we can just round it to 60 as well. We would get 2 times 60 is 120. So we can already see that the only number that is close to 120 here is 118. So that's enough. Try to round them within the reasonable range. So normally we just look at the first digits and we round to whatever it is. So here it's tens, so it's 5 is in the tens. So we round it to the nearest 10. Normally that's fine. Just don't think about it too much. Estimation has to be quick. Yeah. Right, next one. Okay, 23.4 times 19.3. So again, very quick. I'm going to round it to the nearest 10, and this one also to the nearest 10. So the answer should be around 400. You can see again if there's any doubt, so we can round this to 23. So we can round it to 23 times 20, which is 460. So now there's no doubt this is the answer. Okay, let's do the next one, number 24. Here, right, so this is quite a big numbers. Let's try to round them again within the reasonable range. So let's do 543 plus 472 divided by 18.1 plus 10.9. Let's round them all to the, so this is going to be to the nearest 100. It's going to be 500 plus 500 divided by 20 plus 10. That's going to be around 1,000 divided by 30. That's around 33.3. right? And we see that the only digit, the only number which is close to it is 35. So that's the actual answer. Okay, and finally 25, number 25, let's do it here. I will try to separate this a little bit because it becomes a bit messy already. Okay, so 112. Let's round it to 100 times 80 divided by 7 times 5. So it's going to be around, this is going to be 8,000 divided by 35. You could estimate it even further. So we could say that 35 is kind of close to 40. So it should be somewhere around 200. So 8,000 divided by 40 should be somewhere around 200. And if you look at our options, only one of them is remotely close. It's 242. So this should be your answer. Again, try to make it quick. Do not spend too much time on estimation. Okay, I think actually that's it. I thought there's more questions, but that's it for this part. Thank you for attention if you're still here, and see you on the next lesson.